Remember when we did a equation of a line? Anybody remember that? We did it this year, right? And you did it in Algebra 1. Somebody tell me what the equation of a line is. Straight line. What's the equation in slope-intercept form? What is it? Good. Y equals mx plus b. So you should be able to graph something, a straight line, if I give you something like this. So if I give you y equals 3x minus 5, you should be able to look at this and graph it. Would you agree? Because you look at two numbers. You look at this number and you look at this number, and that should tell you something. The first number I would plot if I was going to do a straight line is this one. What is that one right there? It's the y-intercept. What is this one right here? That's the slope. Remember that? That's the slope. So what I'm trying to do is I'm just trying to show you, you're already familiar with this kind of stuff already. You're familiar with seeing an equation and then knowing what those letters stand for. Agreed? All right. So enough of that. What we're going to do is we're not going to do a straight line today. We've already done that. We've had a whole chapter on that way back. What we're going to do, what do you think? We're not going to do an equation of a line. We're going to do an equation of a what? Of a circle, right? All right, yeah, this whole chapter is about circles, so you would think that we're not going to do an equation of a line, but we're going to do the equation of a circle. Everybody with me? So what I want to do is I want to kind of show you how they come up with the equation of the circle. It's kind of a proof, kind of. Right, and I'm going to put that right, I'm going to put the center of the circle right at the origin. Okay? Actually, let's make this a little bit bigger, just so I can write in it. Let's put the center right there at the origin of the x and y axis. Okay, so this is x, of course, and this is y. There we go. Now what we're going to do is I'm just going to take a line, or a radius actually. I could put it anywhere, but I'm just going to put it, I don't know, just right here, just to make it easy. I didn't purposely go like right, splitting this in half or anything. This is not technically a 45 degree. I just put it somewhere in here. Put it in the first quadrant just to make things a little easy for us. And this is what we're going to do. We're actually going to find the length of this radius. That's really what the equation of the circle is. It's basically just the length of the radius. Okay? So if I can find the length of the radius, I've got the equation of the circle. Now I started it at the origin just to make things a little easier for us. I could have taken this circle and moved it all around this x and y axis, and the origin wouldn't be right at the center, or right at the the center of the circle would not be at the origin of my axis. Okay, but right now, just to make it easy, I'll put it right here. So what is this point right here? It's 0, 0, right? It's the origin, so it's 0, 0. What about this point right here? I don't know, because I don't know how far over and I don't know how far up, do I? But let's just be real general. So you went over in which direction? To the right, that's true. But in the, yeah, I probably wasn't real specific on that question, but in the x direction is what I was looking for. You're right, positive, to the right, all that is correct, but I was kind of looking for in the x direction. Now, then I went up in the y direction. You got it? So what I'm going to do, from 0 to this point right here would be how far? It would be x. So from this point 0 on the y-axis all the way up would be y. So I'm going to call this point xy. Everybody okay with that? I think I am. Do I use that or AB? Let me see. No, we use xy. We're fine. Okay. So what do I want to do? The equation of a circle basically is the same thing as finding the what? Let's say the length of the what? The radius. Okay, so if I can find the length of the radius of that circle, right, I basically found the equation of the circle. Now, I'm kind of leaving something out. I kind of made an assumption here that we're always going from the origin, but you could go, the center of the circle could be somewhere else on this x and y axis right here. What we do, the center of the circle, it's not always going to be at 0, 0. The letters that they use for the center of the circle are H and K. Everybody paying attention? All right, so it's H and K. The center of the circle right here is point HK. So we're finding the length of the radius from the center of the circle. Of course, that would be the radius, but that's basically what we're doing right there. Well, let me keep going. I'll show you in a second. Forget the H and K right now. We'll get to that in a second, I promise. But I just wanted to just throw that out there. I just hate for that just to hang without that there. We would find the length of this thing right here. So what do we use? We use a formula that we've already used before, and we've used it quite a bit, actually. How do you find the length of something? Find the what? Not the equation of a line. The distance. Distance formula. Very good. The distance formula. Good. I'm glad it is. It's one of mine, too. So, and I know you're being sarcastic about it. Sorry. Okay, good. So the distance. What is the distance formula? Let's just write that down. It would be what? Remember this? I always put the parentheses and the squared. So, yeah, it's just x1 minus x2 and y1 minus y2. Would you agree? That's just the distance formula in general. What about this one right here? What are my 2 points? X and what? 0. So the distance, okay, between these 2 points is going to be what? X minus 0 squared, right? Plus y minus 0 squared. And try to keep the circle in there. So the distance between the two is going to be what? The square root of just x squared plus y squared. So that's the distance of that radius right there in general. All right, because I don't know exactly where that point is located, but I said it could be anywhere. So it could be x, y. That's the distance between there. Now what we do is this. They write it. I mean, you could just write it like this, but they don't. Now, what am I finding the distance of? I'm not just finding any old distance. It's a specific distance. What? It's the distance of the radius, right? It's how long the radius is. So instead of d, I could put r. Now watch. Let me just show you how they write this thing. They kind of make it a little easier for you, so they don't put that square root there. So if I wanted to get rid of this square root, what would I have to make that r then? If I wanted to get rid of this square root. Square, right, because I square both sides, right? So this is really how they write it. They write r squared equals x squared plus y squared. So that would be the equation of a line, but it's a specific... I said equation of a line, didn't I? I got to make sure I don't say that because I'm used to saying that all year. The equation of the circle, right? This is the equation of a circle, but where is the center of the circle? The center of the circle is at the origin, isn't it? Okay, so the center is at 0, 0. Now look, not every circle has a radius, or the center of the circle at the origin. Let's do this. Tell you what, let's come up here and we'll just copy this, make it a little easier. Copy that, that, and that. Okay, there we go. Did I scooch that circle over? I have. Okay, there we go. Now watch this. Let's use a different color this time. Let's use orange. Oops, I don't want to do this. Watch. I don't want the center of the circle to be at the origin this time. I just did that. Let's put the center of the circle somewhere else, like right there. Is that alright? Okay. So... let's draw another radius. I could draw it anywhere. Let's just draw it right here. Okay, so that's the radius of the circle. Let's put a couple points in here. What did we say we would make this point on the circle? XY, right? Now, this is not 0, 0 now, is it? Remember what I talked about a few minutes ago? It's HK, right. They use HK to represent the center of the circle. Everybody here? Okay. Let's watch. So HK would be the center of the circle, and XY is a point on the circle. So instead of going x minus 0 like we did before, what would we do? Put it right here. So distance equals square root of, put your parentheses in your squared right here. And what would it be? X minus h. Do you see that? And what would the y be? It would be y minus k. Now again, you could write it like this. This would be an acceptable form for the radius of the circle, right? So instead of putting d, because that's distance, what are we doing? We're finding the radius of the circle, aren't we? So we could put r. But instead of putting a big square root here, and again, that would be perfectly acceptable, but for some reason, I guess authors want to make it, they want to streamline it a little bit, make it look a little bit nicer without that big old square root. So guess what they do with that square root? They get rid of it on this side, and then you got to square this side. It's the exact same thing, isn't it? Okay, see this thing right here? That's what you're going to see when you see a book and they say the equation of a circle. This is what it's going to look like right there. Because now it's not just a specific circle with a radius, with a center at the origin. The center can be anywhere on the x and y axis, can it? And where is the center? It's at H and K. Does that make sense? So, what does R represent? It's the radius. Okay, I'm just going to put radius. I'm going to put what these things represent. What does the H, comma, K, what does that ordered pair HK represent? It's the center of the circle. That's right. So, whoops, I can't spell. Let me try this again. Center of the circle. Remember, the center doesn't always have to be at the origin, does it? Sometimes it is, all right, but a lot of times it's not. So it could be anywhere. It could be in the first, second, third, fourth quadrant. Okay, it could be on one of the axes. It could be at the origin. All right, but it doesn't have to be at the origin every time. But that HK tells you where the center of that circle actually is. So with that said, did you write this equation down right here of the circle? Write it, and right next to it, write equation of a circle. Equation of a circle. Okay, put it right next to that. Put little arrows, box it, color it in, make it real pretty, whatever, to remember it. So that's the equation of a circle. It's really not that big of a deal. It's basically just a distance formula, isn't it? Instead of x1 minus x2, what is it? It's just x minus h. Instead of y1 minus y2, it's just y minus k. So it basically is the distance formula, right? Would you agree? Because why is it basically the distance formula? Because the whole idea was just to find the length of that radius right there. All right, and so that's why we use the distance formula. You're going to see how easy this is. You're going to like this probably way better than what you liked an equation of a line. All right. So let's do this. What if I gave you? What if I said this? And y minus 5. All right. I gave you this equation right here. You should be able to tell me two things, and you should be able to graph it, to tell you the truth. You should be able to tell me two things about this and graph it. So what's one of the things you should be able to tell me? Okay, let's find the center of the circle then. So what's the center of this circle? It's an ordered pair, right? It's 3, 5. It's not negative 3, negative 5, is it? Because if you remember your equation, look, it's x minus whatever the h is. The h, right there, it's not negative h, it's x minus whatever the h is and whatever the k is. So hk is your center. So if you have a minus in front of it, all right, you just say the center is, in this case, what? 3, what? 5. You see that? The big mistake is people look at this and they say the center is negative 3, negative 5. It's not. It's x minus whatever the h is. What is the h? The h is just this. It's just a 3, isn't it? Because my equation says x minus whatever the h is. What is my k? It's just 5, isn't it? Okay, so the center of the circle is at 3, 5. What else can you find just by looking at this equation? Remember, I said you can find two things, can't you? The radius and the center, right? You can find two things from that formula. So what do you think the radius of this is? Is it 25?
It's 5.
It's 5, because remember what the equation is. The equation is r squared equals all this stuff, right? So what is r going to be? R is going to be 5, because r squared equals 25, right? Everybody see that? Look, r squared is 25, but we want to find the radius. So how do I find the radius? Take the square root of both sides. Square root of 25 is 5. So the radius is equal to 5. Make sense? So here's what they're going to do. They're going to give you a problem that looks like this, and they're going to ask you to find the center and to find the radius. It's really no big deal. These are actually pretty simple, I think. I really do. I know I say that a lot, and you're probably thinking that, yeah, Mr. Hamrick, you always say they're real easy. But I really think this stuff is kind of easy, to tell you the truth. Even though it's the last lesson in the chapter, or in the book, chapter, I was right. It's the last lesson in the chapter. It's actually, I think, one of the easier ones in the whole chapter. Here's another thing they could do. They could actually tell you the center and the radius, and guess what they're going to ask you to do? Write the equation of the circle. That's right. So let's just make something up. I'm just making these up. Let's let's say the radius of the circle is 3, and let's say the center of the circle, I'm going to make it a little bit more interesting, -2, 7. All right? And what are you trying to do? You're trying to find, or write, whatever they say, I'm not sure exactly what they say, but find the, what? Equation of the circle. Okay? So, what is it? It's let's write it down, just in case you forget, since you're kind of new at this. Yeah, it would be. I heard that a couple times. It would be 9. That's right, because the radius is 3. What do we put here? We go r squared, right? So 3 squared is 9 equals, okay, watch. I'm going to set this up like this. So it would be x minus whatever the h is. So what would it be? So you said it. It'd be +2. That's right. It would be +2 because it's x minus what? A -2. Minus a -2 minus a negative is +2. You see that? That's the part that gets people a little bit mixed up. But it would be x +2. What would this be? It'd be y minus, and what's this number? It's just a 7, so we put a 7 right there. And there, you're done. That's the equation of the circle with a radius of 3 and the center at -2, 7. Told you it was easy, right? I'm not lying. Yes, sir. We will have to graph the circle. I'm glad you brought that up. Okay? So we might as well do it on this one, right? And we just have enough time to do this. It actually is pretty easy. I'll show you.
It is.
I promise. So, where's our center? It's at -2, 7, isn't it? So let's pretend. Watch this. Let's pretend we didn't know any of this stuff right here. All right. We only knew this thing right here, and I asked you to graph this thing. All right. So first thing I would do is find the center of the circle. Where is it? It's -2, -7. And I'm going to have to extend this down a little bit so I can get a 7 in there. It's -2, +7. Right, that's what I said. Not really. Okay, here we go. That's a little bit better, don't you think? Alright, let me get the right color here. Let's go orange again. Go color coordinated here. So it's -2, +7. -2, +7. 1, 2, 3, 4, 5, 6, 7. So we'd put a dot right there. What does that mean? That's the what? Center of the circle. Okay, what's the radius of this circle? Is it? It's 3, right. R squared is 9, but R is 3. So what in the world do we do? This is what I do. I count over 3. 1, 2, and then it would be 3 right here, wouldn't it? Because I'm at -2 here. Then I'd go 3 here. 1, 2, 3, right? I'd go 3 this way. 1, 2, 3. This might not be very accurate, but you'll get the idea. 1, 2, 3, about like this. And then what do? Now, I'll try to draw it, but it gets a little ugly. Yeah, well, you don't just connect them, but you make a circle out of it, okay? Yeah, I told you not to laugh. Oh, my goodness. See, that's a beautiful circle. See, you're so used to my perfect circles, you know, that with my computer program. Yeah, wait till you try it. You won't be laughing then. All right. Well, you know how it is. Well, there it is. That's supposed to be a circle. You get the idea. Told you not to laugh at me. Yes. Because you got to go 3 this way, 3 this way, 3 this way, 3 this way. So the radius of the circle is 3. It's 3 everywhere on that circle, right? So it's supposed to be anyway. That circle maybe not so much. All right, hush. Shh, shh, shh. So yeah, you're going from the center. You're going 3 this way. So I count over 3. 1, 2, 3. I count up 3. 1, 2, 3. Count to the left 3. 1, 2, 3. Count down 3. 1, 2, 3. All right. And that means that's the radius, isn't it? At all those points, the radius is 3. And you try your best, okay, to make a nice, pretty circle. That's a little bit odd-shaped, but there you go. All right, and that's pretty much it. That's how you do that lesson. That's not that hard at all, is it? I don't think it is. That's it. I told you. I wouldn't. You guys use that too.
How many more chapters do you want?
Yeah, too easily, and you shouldn't say that at all. What's that?
How many more chapters do you have?
Yes.
Right, because you know what it stands for, so don't say it. I don't know. I don't know how many.
Homework.
Yeah,
How
it's
many more chapters do you have left to do?
I don't know. As many as we get done. I don't know. All depends on how fast we go. Who knows? I don't know. Just worry about this. One game at a time, right? You know what they say? So there you go. That's your homework for tonight. Get it done. Enjoy it. See you tomorrow.